Are large language models like OpenAI's GPT-4 so powerful that everyone should have fair access to them through a public utility? And if so, could their massive computational and energy requirements be served by the similarly massive compute that's simply discarded after mining Bitcoin transactions? The intellectual power and productivity that can now be summoned with just a mouse click from modern generative AI language models promises to transform the essence of knowledge work. Healthy debate exists on whether such a powerful new technology is too great to be concentrated in the hands of a small number of companies and individuals. Ensuring fair access to this technology would be akin to existing frameworks that are already well understood in the public utility space for regulating broadband or electricity or even healthcare. It's not difficult to imagine AI access becoming just as essential as these resources are today. If an LLM were to be operated as a public good for the benefit of all, it would indeed be a sophisticated endeavor, requiring technical skill, administration, and most of all, mountains of compute. It's estimated that a cluster of 10,000 GPUs was used to train ChatGPT over a period of months. Enter blockchain. This may be the perfect distributed system and resource aggregator upon which to build such an LLM utility. Decentralized miners in so-called proof-of-work blockchains like Bitcoin consume enormous amounts of energy to cryptographically prove a set of transactions. These proofs, crowdsourced from millions of miners around the world, ensure that commerce and settlement with Bitcoin is fast, secure, and autonomous, rather than relying on a third party. The global market for Bitcoin of around $500 billion as of today indicates that this alone has real monetary value. But one of the largest tragedies, in my opinion, is that the results of these computations are effectively thrown away once the transactions are settled. Is there a proof-of-work algorithm that can harness all this compute for some sufficiently useful monolithic purpose? Further, can this be done while still retaining the properties required by blockchains to secure their consensus with the proof-of-work algorithm? For instance, Bitcoin needs to trust the proof-of-work calculation is unique, too difficult to fake, quickly verified, and that you can adjust the difficulty so that the hash power has the right time between blocks to solve. My proposal is train a large language model as a public utility, leveraging Bitcoin proof-of-work computation. How might this be done tactically? At a high level, such a project would need to execute the following 6 steps. Collect LLM training content from a set list of sources at some time interval. Format and partition the content into blocks of raw text inputs for parallelized neural network training. Train the model in a standard, reproducible way so that competing miners would achieve the same result. Then the parameter weights in that final trained model are the numerical output or the solution to the proof-of-work algorithm. Verify the solution and distribute block rewards to the winning miners. Hash the final model weights into a single digest and tie it into the blockchain. And now the model weights are updated and ready to deploy, and you have your large language model which can serve inferences and predictions. So let's walk briefly through discussion of each of those. 1, collecting data, scraping, and preparing it. Probably at least once a day, you'd have to do this to keep up with current events. This is a whole discipline in and of itself, but it's well understood from training previous language models and from the indexing step of running search engines. It's reasonable to assume a preference for fine-tuning or updating some foundational base model rather than training from scratch every day. You could store the relevant data files in the model files programmatically as a matter of public record using smart contracts built on a blockchain native storage platform such as Filecoin. All of this data collection and storage would require an auxiliary administrative system, since the Bitcoin compute cannot be flexible enough to train the model and do these other things. I'll say more about that later. 2, format and partition the content. One trains an LLM by feeding it troves of raw text, so it can learn to predict the next best word trillions of times. Since this can take months on a cluster of GPUs, we'll need to subdivide the problem into parallel processes to speed things up. I estimate 1,000 subprocesses. I won't go into it too deeply here, so check the longer article for details, but suffice it to say that this is a tricky problem. There's already a lot of research on it, but it's focused on parallel machines that are also co-located to minimize the overhead of high bandwidth communication that's needed to repeatedly sync the threaded tasks. New advances would be needed in the area of geographically distributed training. 3. Train the model in a standard reproducible way. Assuming we find some method to obtain the content and to parallelize the training, the next step would be to conduct the actual training. Assuming each miner gets randomly assigned to one of 1,000 partitions, there would be network-specified parameters about how to initialize and train the model. For example, initialize the weight matrix using a nonce for that specific block as the random seed. Train for exactly 100 epochs, use an atom optimizer, and a learning rate of 0.05. If the network grows or changes, these parameters could be adjusted to tune that. Maybe you do 101 epochs. Maybe you change the learning rate to 0.04. The parameter weights in the final trained model are the numerical output or solution to the proof of work algorithm. Once the training of all subproblems is complete, they would need to be recombined to produce the entire model. Step 4, verification, reaching consensus. Once the solution is complete, there needs to be a fast way to check it for validity before finishing the existing consensus process. This is another tricky one. Proof of work cryptography needs to be hard to calculate, but easy to verify. This is one of the strengths of the existing Bitcoin proof of work mechanism, that only a few mathematical operations are required to verify the provided solution is valid. If there's no fast way to verify our trained neural network is valid, a cabal of miners might collude to submit some random set of parameter weights and fraudulently receive block rewards. Some possible ideas would be to actually deploy and run the model and test it against some of the industry standard language model benchmarks, or see if the model can recite some code phrase specific to that block's training data. The ideal solution would be if there's some set of mathematical proofs or properties detectable in the weight matrix itself that would avoid the need to run the language model. Step 5, hashing the model weights to verify that the blockchain is connected. To obtain a hash as a unique identifier for the whole block, you can take the hash of the transactions, you can take the hash of the model weights, hash them together into a new hash, and then hash that with the previous block's hash. That way you know all of the information is threaded into the fabric of the blockchain and you can mathematically verify the lineage. Finally, step 6, deploy the model and run it with these new weights. We need some way to actually run this model that we've done all of these things to produce. This would be yet another auxiliary system with large compute and bandwidth needs, and perhaps could also be part of some supporting blockchain like we've mentioned. In conclusion, there are many interesting and potentially valuable concepts to continue exploring here, but there are still significant uncertainties and potential blockers to realizing the vision of this thought experiment as currently stated. For one, part of the appeal and success of Bitcoin depends on its unchanging nature. The code base is largely set it and forget it. Many participate or invest based on the resilience to tampering with those pre-programmed policies. Additionally, Bitcoin's tremendous hash power may ultimately be limited to a purpose-built designer proof-of-work algorithm because of its complex design constraints. And even if it can be harnessed to hoist the long pole in the tent, so to speak, of training an LLM, there are numerous costly functions that would need to be supported elsewhere, such as what we talked about: data collection, parsing, parallelizing, archive, validation, deployment, and ultimately inference. Perhaps these auxiliary functions could be incentivized and powered by an independent blockchain alongside of Bitcoin. Or setting Bitcoin aside entirely, perhaps this whole enchilada, LLM training plus the auxiliary functions, is useful enough to warrant creating a new dedicated blockchain to bootstrap an LLM utility. I'd be interested to hear your reaction to this thought experiment. Should LLMs be a public utility? What are the biggest blockers to using Bitcoin to train it? Or some other new blockchain? Are there different ways to construct an LLM as a public utility? Or are there other ideas I've discussed that might be useful elsewhere in and of themselves?